Hundreds of advanced diplomatic ships launch from Earth and soar into deep space, heading toward a destination humanity never thought they'd reach so soon. When they arrive, they're greeted by hundreds of mysterious alien vessels. This isn't a movie plot. It's the imagined scenario of what first contact with an extraterrestrial civilization could look like. Scientists believe this possibility isn't that far-fetched. A nearby star system has already sparked global attention. It's called Proxima Centauri, and it's not just any star. It's the closest one to our solar system, lying just 4.2 light-years away. That means light takes a little over 4 years to reach us from there, while sunlight only takes 8 minutes to hit Earth. Proxima Centauri itself is a red dwarf star. It's much smaller than our Sun, around 7 times smaller to be exact, and only about 50% larger than Jupiter. Despite its size, it has a fascinating feature that has captured the attention of scientists worldwide. This star has a planet orbiting it, known as Proxima Centauri b. And this planet could be the key to answering one of humanity's oldest questions. Are we alone in the universe? Proxima Centauri b is roughly 17% larger than Earth and 10% more massive. It orbits its star at a distance of just 4.5 million miles, whereas Earth is 93 million miles from the Sun. At first glance, that sounds like it should be way too close for life. But Proxima Centauri emits far less light and heat than our Sun. This means Proxima Centauri b sits in what's called the habitable zone, a sweet spot where conditions might allow liquid water to exist. In theory, it's not too hot and not too cold, making it a candidate for hosting life. But this idea comes with a catch. The star it orbits is incredibly unstable. Its brightness fluctuates wildly, often throwing violent tantrums in the form of massive radiation bursts that could sterilize the surface of the planet. In 2017, astronomers observed a dramatic event. Proxima Centauri suddenly brightened 1,000 times in just 10 seconds. A solar flare powerful enough to blanket Proxima Centauri b in deadly radiation. Before that, there had already been another flare, albeit smaller. Together, these events would have flooded the planet with harmful rays. Even if Proxima Centauri b had an atmosphere or oceans, this radiation might strip them away. In fact, the planet receives 400 times more X-ray radiation than Earth does, making it nearly impossible for complex life to thrive, at least on the sun-facing side. And here's where it gets interesting. Proxima Centauri b is thought to be tidally locked to its star. That means the same side always faces the star, just like our moon always shows the same face to Earth. One hemisphere is forever bathed in light and radiation, while the other remains in permanent darkness. Some scientists have proposed a bold idea. If there is intelligent life on this planet, it might be living on the dark side, sheltered from the deadly rays. And here's where the mystery deepens. In 2019, a strange radio signal was picked up by Earth-based instruments, seemingly originating from the direction of Proxima Centauri. The signal wasn't a random blip. It lasted 30 days and consisted of a bright, long-duration optical flare combined with intense, coherent radio bursts. Naturally, this sparked speculation. Could this be a message from an alien civilization living on the dark side of the planet, or perhaps from one of its hypothetical moons? While some scientists quickly labeled the signal as potential Earth-based interference, others weren't so sure. They believed it might indeed be artificial, perhaps even intentional. Sadly, the signal has never been detected again. But what if it truly was a transmission from an intelligent species trying to make contact? Soon we might be able to find out. Enter the James Webb Space Telescope, a technological marvel designed to change our understanding of the cosmos. It was launched into space to a point between Earth and the Sun where gravitational forces are perfectly balanced. Unlike telescopes on Earth, Webb has no atmosphere or clouds to contend with, allowing it to peer deep into the universe with incredible clarity. Built as the successor to the iconic Hubble telescope, Webb cost nearly $10 billion and boasts a mirror the size of a boxing ring. This massive mirror gives it unparalleled power to capture faint light from incredibly distant objects. That means James Webb can essentially look back in time. Since light from far-off objects takes years, even billions of years, to reach us, observing it lets us see how the universe looked shortly after the Big Bang. Webb will help us witness the formation of the first galaxies and stars, offering a cosmic time machine to the early universe. But it's not just about deep space. Webb also has its sights set on places like Proxima Centauri b. Its instruments are sensitive enough to detect not just heat and atmosphere, but possibly even artificial light. That's right, city lights from an alien civilization, if they exist, could potentially be spotted. If beings do exist on the dark side of Proxima Centauri b, they'd need some form of artificial lighting to survive. Webb might be able to detect those unnatural light wavelengths, distinguishing them from the natural glow of the star itself. Imagine if we catch even the faintest glimmer of something artificial. That would be the first concrete sign that intelligent life exists beyond Earth. But of course, scientists are cautious. Light detection is complex, and interpreting data from deep space always carries the risk of false positives. The only way to confirm such a discovery is to physically explore the planet or send a probe. And that's where we hit the next big challenge: distance. Even though Proxima Centauri is our cosmic neighbor, getting there is far from easy. For context, Voyager 1, the farthest human-made object, has taken over 40 years just to exit our solar system. Proxima Centauri is still more than 25 trillion miles away. A traditional spacecraft would take over 70,000 years to get there. Clearly, we need a new approach. Some scientists are working on it. They propose sending ultralight microprobes no heavier than sewing needles. These probes would be launched into space and equipped with reflective sails. Once deployed, these sails would be hit by powerful laser beams from Earth, pushing the probes to a stunning speed, around 20% of the speed of light. At that velocity, they could reach Proxima Centauri in just over 20 years. That would be a record-breaking achievement in space travel. After arriving, we'd still need to wait several more years for data to make its way back to Earth. If this project succeeds, it could redefine humanity's reach in the cosmos. We wouldn't just be looking at exoplanets, we'd be visiting them, even if only through robotic eyes. But Proxima Centauri b isn't the only world of interest. One of James Webb's main missions is to explore a wide range of potentially habitable exoplanets. Its instruments can scan for rocky planets with Earth-like temperatures orbiting nearby stars. In fact, scientists expect a massive boom in exoplanet discovery. The telescope will investigate around 24 nearby systems in detail, searching not only for planets but even for their moons. And these discoveries aren't just scientific milestones, they're also narrowing down the most likely places where life could exist. Back in our own solar system, Webb is helping explore fascinating moons like Europa, one of Jupiter's icy satellites. Though Europa appears frozen on the outside, scientists believe that tidal forces from Jupiter may heat its core, keeping a subsurface ocean in a liquid state. If true, it could harbor microbial life. Similarly, Saturn's moon Enceladus is geologically active, with geysers spraying water vapor and organic molecules into space. Webb's infrared sensors are capable of peering through the ice and vapor to search for biosignatures, chemical traces that suggest life. The telescope is set to operate for about 6 years, but scientists already have their eyes on its successor, LUVOIR, short for Large UV Optical Infrared Surveyor. Scheduled for launch in 2039, LUVOIR will have a mirror twice as large as Webb's and nearly 7 times bigger than Hubble's. It will be sent 1 million miles from Earth using a massive super-heavy rocket and will be designed to search for biosignatures and potentially habitable worlds across the galaxy. And who knows? By then, we might develop technologies to travel faster, possibly even approaching the speed of light. If LUVOIR identifies an Earth-like planet, the next step could be to send robotic explorers, or even a human team. That opens up the real possibility of a face-to-face meeting with an extraterrestrial civilization. Imagine the implications of such a discovery, not just scientifically but culturally, philosophically, and spiritually. For now, though, the James Webb Space Telescope is already delivering breathtaking results. One recent detection sent ripples through the scientific community, a faint but persistent glow observed from a staggering 7 trillion miles away. Could this be light from an alien city, an advanced civilization shining through the darkness? This moment marked a historic milestone, the very first time scientists had ever detected any kind of light coming from a small, relatively cool exoplanet that resembles the rocky worlds in our own solar system. Until now, no telescope had been powerful or sensitive enough to catch the dim mid-infrared glow emitted by such distant, faint objects. When the TRAPPIST-1 system with its 7 exoplanets was initially discovered, the entire astronomical community was buzzing with excitement. It was rare to find not just 1 but 7 Earth-sized planets located in the habitable zone of their host star, making it a dream target. The habitable zone, also known as the Goldilocks zone, refers to the perfect orbital distance from a star where liquid water could theoretically exist on the surface of a planet. Not too hot, not too cold. That's what made the TRAPPIST-1 system such a big deal. With several planets potentially falling in this sweet spot, it was considered one of the most promising places to look for life or at least an atmosphere that could support it. But before we let our imaginations run wild, there's something important to understand. These planets, while fascinating, are incredibly far away from us. In fact, they're so distant that any hopes of traveling there, even with our most advanced space technologies, are completely out of the question for now. TRAPPIST-1 is located 235 trillion miles away from Earth. To put that in perspective, it's about 39 light-years away, which means even if we could travel at the speed of light, it would still take nearly 4 decades to get there. Adding to the mystery, the star that these planets orbit is much smaller and redder than our Sun. It belongs to a class of stars known as M-dwarfs. These M-dwarfs are actually the most common type of stars in our Milky Way galaxy. There are about twice as many M-dwarfs as there are Sun-like stars. Interestingly, they're also twice as likely to host rocky planets in their orbit. This combination makes them prime candidates for astronomers who are trying to find planets that might harbor life. Observing rocky exoplanets around these stars is more convenient too, since the stars are dimmer and smaller, making it easier to detect subtle changes in light when a planet passes in front. But of course there's always a trade-off. As promising as M-dwarfs may sound, they come with a major problem. These stars tend to be far more active than our Sun. They flare frequently, releasing intense bursts of high-energy radiation that could be incredibly damaging to any surrounding planets. These flares could strip away atmospheres and make life nearly impossible. So, even if a planet orbits within the habitable zone, the stellar activity could pose a serious threat. That's one of the concerns scientists have with TRAPPIST-1's planets. One of the planets in particular, TRAPPIST-1b, has been a focus of recent research to determine if it has an atmosphere. Earlier attempts to study TRAPPIST-1b didn't produce conclusive results because the instruments weren't sensitive enough to tell whether this planet had an atmosphere or if it was just a lifeless rock. But now, with the power of the James Webb Space Telescope, we know more. One key fact is that TRAPPIST-1b is tidally locked, which means one side of the planet always faces the star while the other side remains in eternal darkness. This creates extreme conditions, unless an atmosphere exists to help distribute the heat from the day side to the night side. Simulations showed that if TRAPPIST-1b had an atmosphere, the temperature difference between the two sides would be less extreme. The air would act like a conveyor belt, moving heat around the planet and making the temperature more stable. But that's not what the James Webb Telescope found. Instead, it recorded surface temperatures that were way hotter than expected, too hot for an atmosphere to be present. This lack of atmospheric insulation ruled out any possibility of habitability for TRAPPIST-1b and dashed earlier hopes. Still, this discovery was a win for science in another very important way. The real headline wasn't the disappointing truth about TRAPPIST-1b, but the capability of the James Webb Telescope itself. This was proof that it could measure the temperatures and detect atmospheric conditions of rocky exoplanets, something no other telescope had been able to do before. That means we now have a tool powerful enough to explore other distant, possibly habitable worlds with incredible precision. This wasn't just a scientific result, it was a technological breakthrough. James Webb just opened the door for a whole new era in exoplanet exploration, and the possibilities are thrilling. Even though the environment surrounding the James Webb Space Telescope is dark, cold, and hostile, devoid of oxygen, water, or any signs of life, the telescope continues to function with remarkable precision. Its primary mission is to look deep into the cosmos, to find galaxies that formed billions of years ago, and to observe the birthplaces of stars and planetary systems. But as it was busy scanning the distant corners of space, something unexpected showed up on its instruments. A strange hybrid between a planet and a star. Something that didn't quite fit into any normal category. This unusual object is known as VHS 1256b, a brown dwarf with very strange cloud formations. Brown dwarfs are cosmic oddities. They're bigger than most planets but not massive enough to kickstart the fusion process that powers stars. So they sit in this in-between state. They do emit some light and heat of their own, but not nearly as much as stars do. They're also incredibly hot. Although they're called brown dwarfs, that's a bit misleading. These objects aren't actually brown. They can appear orange, magenta, or other colors, depending on how their light is processed by our instruments. The brown dwarf VHS 1256b is massive, almost 20 times larger than Jupiter. It's locked in a slow orbit around two red dwarf stars, and its orbital path is so wide that it takes nearly 17,000 years to complete one full revolution. Astronomers first spotted this object back in 2016, but at that time, they didn't classify it as a brown dwarf. They couldn't quite make sense of its reddish glow, and the lack of data meant they had more questions than answers. But now, thanks to the James Webb Telescope, they've finally cracked the mystery. What they discovered was fascinating. The clouds on VHS 1256b are unlike anything we've seen before. Here on Earth, clouds are mostly made of water vapor. But on this bizarre world, the clouds are made of sand. Not regular beach sand, of course, but microscopic particles of silicates, minerals that make up a large portion of Earth's crust. For years, scientists had theorized about the possibility of sand clouds in the atmospheres of hot exoplanets and brown dwarfs. But this discovery provided the first real observational evidence that such clouds actually exist in space. The sand particles are incredibly tiny, most of them less than a micron in size. That's about 1/25th of a thousandth of an inch, which is similar in scale to the particles found in Earth's smog. The James Webb data also revealed more about this object's atmosphere. It contains not just silicate particles but also water, methane, and other chemicals. What's even more surprising is that the atmosphere appears to be dynamic and chaotic, constantly shifting and changing in violent weather patterns. This isn't a calm place, it's a stormy, wild world filled with clouds of space sand. Another fascinating detail was the detection of carbon dioxide, something that's extremely rare in exoplanet studies. This marked only the second time that carbon dioxide had been confirmed in a planet outside our solar system. The detection of multiple gases helps scientists better understand the chemical composition and possible evolution of these exotic objects. It also proves how powerful the James Webb Space Telescope really is. Compared to Hubble, Webb is a beast. It's about 100 times more powerful, capable of detecting the faintest signals from the deepest corners of the universe with incredible detail. Despite its enormous capabilities, the James Webb Space Telescope is surprisingly lightweight for its size. It's about the size of a tennis court and 3 stories tall, yet its mirrors are the lightest large telescope mirrors ever built. During construction, engineers managed to reduce each mirror's weight by 92% from its original mass. Each one weighs just 44 pounds. The mirrors may appear gold, but they're not made entirely of gold. They're actually constructed from beryllium, a lightweight, steel-gray metal known for being both strong and brittle. The gold you see is just a super-thin coating. Gold was used because it reflects infrared light exceptionally well, which is crucial for Webb's ability to observe the universe. But pure gold expands and contracts with temperature changes, making it unsuitable as a base material. That's why only a tiny amount of gold was used, less than 2 ounces in total. To operate effectively, the telescope must stay extremely cold. It cools itself down to around -370 degrees Fahrenheit. That's colder than liquid nitrogen. A 5-layered sunshield surrounds the telescope, blocking sunlight and keeping the internal instruments cold enough to function properly. Webb was launched from a site near the equator. That location wasn't chosen randomly, it was strategic. Earth rotates fastest at the equator, giving the rocket carrying Webb a little extra boost to escape gravity. Once in space, the telescope settled into an orbit about 1 million miles from Earth. It doesn't orbit our planet. Instead, it orbits the Sun in a special gravitationally stable point called Lagrange Point 2. While Webb wasn't designed to be serviced, there's hope that robotic missions might one day refuel it, allowing this incredible observatory to continue operating far beyond its expected lifespan. But as mind-blowing as VHS 1256b is, it's far from the only strange world out there. Let's explore a few more of the weirdest exoplanets astronomers have found so far. One of them is GJ504b, located in the Virgo constellation. This one stands out for its color, an eye-catching magenta hue that glows in infrared. It's a gas giant, and it orbits its star at a distance 9 times greater than the distance between Jupiter and the Sun. Because it formed recently, it's still cooling off, and the residual heat gives it that unique pinkish appearance. When you think about it, the Hubble Space Telescope is like an old master of space observation. It's been out there for over 30 years, peering into the depths of the cosmos with unmatched dedication. Named after the legendary astronomer Edwin Hubble, it was built and launched by NASA and is part of an elite group known as NASA's Great Observatories. This group also includes other heavy hitters like the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. Each one specializes in capturing different wavelengths of light, and together they've transformed our understanding of the universe. The Hubble telescope was designed to answer some of the most fundamental questions about space: how galaxies form and evolve, how stars live and die, and how the universe itself has been changing over time. And it didn't disappoint. Over the decades, it has delivered incredible insights, including providing some of the most convincing evidence for dark matter, and even helping scientists refine the estimated rate of the universe's expansion. Its ability to see deep into space with remarkable clarity allowed it to make discoveries that simply wouldn't have been possible from the ground. One of Hubble's most iconic contributions is a breathtaking image known as the Pillars of Creation. Captured in 1995, this photo showcases towering columns of gas and dust inside the Eagle Nebula, a place where new stars are being born. These massive cosmic structures appear almost like fingers reaching out into space, glowing against a vibrant backdrop. The image quickly became symbolic of Hubble's power, capturing both the imagination of the public and the curiosity of scientists. It's not just a pretty picture, it's a glimpse into the very factory where stars are created. But Hubble's journey wasn't always smooth sailing. Not long after its launch, scientists discovered a flaw in its main mirror. This defect distorted the telescope's ability to focus light, rendering its early images blurry and disappointing. Fortunately, NASA launched a repair mission in 1994, where astronauts aboard the Space Shuttle successfully installed corrective optics. Since then, Hubble has functioned perfectly, proving its resilience and becoming one of the most productive scientific instruments in history. It's a story of redemption that showcases human ingenuity and persistence in space exploration. In more recent years, Hubble uncovered something quite strange, a dim, unexplained glow surrounding our solar system. This eerie light doesn't seem to come from stars, galaxies, or even the dust in our solar system's plane. It has been dubbed ghost light, and its source remains a mystery. Scientists believe it might be caused by tiny, icy particles from comets scattered far out in space, but there's no concrete evidence yet. It's an open question, and one that hints at the possibility of new phenomena that we've never studied or understood before. We often associate space discoveries with bright, obvious things like stars, planets, or galaxies. But sometimes, what's most intriguing is the faint glow that comes from places where we never expected to see light at all, like the gaps between planets. This mysterious glow might be coming from deep within our solar system or even hint at new physical processes. Voyager 1, for example, also detected light at the very edge of our solar system, sparking even more curiosity. So why haven't we noticed it before? Because most scientists simply weren't looking for it. Most of the time, images from telescopes like Hubble are focused on faraway objects, so the light from nearer sources is usually filtered out or ignored. But when researchers took a closer look, they realized we've never really studied the total amount of ambient light in the universe. Now that they're doing so, they've discovered something puzzling. There's more light out there than we can account for. They searched for faint, previously unnoticed galaxies that could explain the excess, but even those weren't enough. It's not a lot of light, roughly equal to 10 fireflies, but it matters. This tiny glow, although subtle, could hold the key to understanding aspects of the universe we've missed. It challenges the idea that we have a complete grasp of what's out there. Could there be hidden cosmic structures? Unknown sources of radiation? Hubble has once again shown us that the universe still holds secrets waiting to be uncovered. One of its most remarkable contributions is helping us better understand dark matter, a substance we can't see but know exists because of its gravitational effects. Hubble was even able to help scientists create 3D maps of this invisible material. These maps reveal that dark matter isn't evenly spread throughout the cosmos. Instead, it's clumping together, showing a structure that mirrors how gravity behaves over time. About 23% of the universe is made up of this mysterious stuff, and Hubble's precise observations have given us the most detailed insights yet. Beyond dark matter, Hubble has helped us learn more about objects in our own solar system too. It discovered 2 additional moons of Pluto, named Nix and Hydra, and observed changes on Pluto's surface. It even measured the mass of Eris, a dwarf planet bigger than Pluto. These observations led scientists to take a fresh look at what defines a planet. Eventually, Pluto was reclassified as a dwarf planet, a move that sparked debate worldwide. Still, it opened the door to discovering many other icy bodies in the Kuiper Belt, a region at the edge of our solar system. This broader perspective helps us trace the formation and history of our solar neighborhood. But Hubble didn't stop there. It also gave us valuable information about gamma-ray bursts, the most energetic explosions in the universe. For years, their origin was a mystery, but Hubble helped crack the code. By pinpointing their locations, Hubble found that gamma-ray bursts occur in galaxies where new stars are rapidly forming, and where heavier elements are relatively rare. This suggests that the bursts are caused by massive stars collapsing into black holes. These stars, having less heavy material, can more easily collapse under their own gravity, creating powerful explosions in the process. Speaking of cosmic collisions, in 1994, a dramatic event took place when the Shoemaker-Levy 9 comet smashed into Jupiter. Hubble captured this in spectacular detail, showing multiple impacts, massive fireballs, and even dark scars left on Jupiter's surface. This event fascinated the public and provided scientists with a unique opportunity to study Jupiter's atmosphere under extreme conditions. It was a real-time cosmic drama unfolding in front of our eyes, and Hubble was the front-row witness. Moving on from comets to cosmic monsters, black holes. These are regions of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse at the end of their lives, compressing their matter into an unimaginably small and dense point. Hubble has helped us understand where these black holes are and what they do. Specifically, it found that almost every galaxy with a central bulge of stars likely harbors a supermassive black hole at its core. Even more fascinating, there's a strong connection between the size of these black holes and the size of the galaxies that host them. This suggests a relationship that could help us understand how galaxies, and perhaps the entire universe, have evolved over time. So, what exactly is a supermassive black hole? Imagine something millions or even billions of times heavier than our Sun, sitting silently at the heart of a galaxy, pulling in stars and gas with ease. These are not just massive, they're monstrous. Their gravitational pull is so powerful that they can swallow entire star systems. Scientists believe these black holes could play a critical role in galaxy formation, shaping their structure and influencing how stars and matter behave around them. Thanks to Hubble's sharp vision, we've been able to spot these enigmatic beasts and study their surroundings. But there's another question Hubble helped answer, one that puzzled astronomers for decades. How old is the universe? Before Hubble, estimates varied wildly, and some calculations suggested that stars were older than the universe itself. Obviously, that didn't make sense. Using Hubble's precise measurements, especially its ability to observe distant galaxies and track their movement, scientists were finally able to determine a more accurate expansion rate of the universe. This led to a widely accepted age of about 13.75 billion years. Knowing the universe's age is critical because it serves as the foundation for understanding everything else: how stars form, how galaxies evolve, and how cosmic events unfold. Most astronomers now agree that the universe began with a massive, extremely hot explosion known as the Big Bang. We weren't there to witness it, but we can still see the evidence. Think of it like a baby photo of the universe, except this one is 14 billion years old. Scientists managed to take this incredible snapshot using NASA's Wilkinson Microwave Anisotropy Probe, or WMAP for short. This satellite was launched to measure the faint heat left over from the Big Bang, and the image it returned became one of the most important in cosmology. It's a detailed picture of what the universe looked like in its infancy, and it confirmed many aspects of modern cosmological theory. The cosmic microwave background, or CMB, is one of the most fascinating and mind-blowing discoveries in all of cosmology. It's basically a ghostly glow that fills the entire universe. When we look up into the night sky with regular telescopes, we mostly see stars, galaxies, and a whole lot of darkness in between. But if we switch to radio telescopes, especially those tuned to microwaves, something amazing appears. That seemingly empty space isn't actually empty, it's glowing with the faint light of the ancient universe. It's not coming from any stars or galaxies. This is the oldest light in the universe. This glow is the cosmic microwave background, and it's everywhere, an invisible blanket of light stretched across the cosmos. What's even more surprising is how cold it is. The CMB is chilling at an unbelievably low temperature of -455 degrees Fahrenheit, or about 2.7 Kelvin. That's colder than anything you'll ever experience on Earth, even in the harshest winter. This faint light was born around 380,000 years after the Big Bang, which itself occurred almost 14 billion years ago. So, when we observe this radiation, we're actually looking back in time, at the baby picture of the universe. In the beginning, the universe wasn't the quiet, cold place we know today. It was hot, unimaginably hot. Around 500 million degrees Fahrenheit, filled with a dense, glowing plasma of free electrons and protons zooming around like particles in a raging storm. It was a chaotic sea of energy where atoms couldn't form, and light couldn't travel freely. Any photons trying to escape were constantly scattered by the wild electrons, making the whole universe look like a dense fog. It was like trying to see through a fogged-up car windshield during a thunderstorm. But then, something incredible happened. The universe began to expand. Just like blowing up a balloon, the universe stretched in all directions. And as it expanded, it also cooled. By the time it was about 380,000 years old, it had cooled enough for electrons and protons to finally slow down and bond, forming neutral hydrogen atoms. This phase change was a turning point. It cleared the fog. The universe went from being opaque to transparent. Scientists call this the recombination epoch. From that moment on, light could finally travel through space without being blocked. The light released at that magical moment of recombination began its journey across the cosmos. And since light travels at a fixed speed, about 186,000 miles per second, it took billions of years for that ancient light to reach us. That light, now cooled into microwaves, is what we detect today as the CMB. It's like receiving a photograph from the universe's earliest memories. But as this light traveled across the vast, evolving cosmos, it encountered stars, galaxies, dust clouds, and all sorts of cosmic obstacles, which slightly altered its properties along the way. One of the biggest challenges in studying the CMB is that it gets distorted by structures in the universe. For example, galaxy clusters, huge groups of galaxies, can bend, absorb, or scatter the ancient light. These effects leave smudges or fingerprints on the CMB, making it harder to interpret. Imagine trying to read an ancient manuscript, but someone has spilled ink on it. That's why scientists rely on powerful computers and sophisticated techniques to clean up the CMB's data, removing interference and getting as clear a picture as possible. And even when cleaned up, the CMB isn't completely smooth. It has tiny fluctuations, little bumps and dips in temperature and density. These patterns are extremely important because they carry the fingerprints of the early universe's structure. They show us where matter began to clump together, eventually forming stars, galaxies, and clusters. Tools like the Cosmic Background Explorer (COBE) and the Wilkinson Microwave Anisotropy Probe (WMAP) have been used to map out these fluctuations with incredible precision, revealing a cosmic blueprint of how the universe evolved. COBE was launched in 1989 and operated until 1993. It gave us the first-ever map of the CMB, confirming its existence and uniformity. Later, WMAP offered even sharper data, allowing scientists to measure the age, composition, and shape of the universe with astonishing accuracy. Thanks to these observations, we now know that the universe isn't just made of the stuff we see. In fact, the stuff we can observe, stars, planets, gas, makes up only about 5% of the entire cosmos. The rest is made up of mysterious and invisible substances. The other 95% of the universe is split between dark matter and dark energy. Dark matter, which makes up about 27%, is an invisible substance that holds galaxies together with its gravity. Dark energy, on the other hand, is even more mysterious. Making up about 68% of the universe, it's the force responsible for accelerating the expansion of space. Imagine the universe as a cosmic pie. Only a small slice of it is made from ingredients we understand. The rest remains an enigma, hidden in the dark, pushing the boundaries of our scientific knowledge. Studying the CMB also tells us about the first moments after the Big Bang. Right at the beginning, the universe was tiny, way smaller than a proton. It existed in a quantum state where the normal rules of physics didn't apply. Particles were popping in and out of existence, borrowing energy from the future and disappearing. This bizarre, chaotic soup of matter and energy was governed by quantum mechanics, a realm where things behave in ways we still struggle to fully understand. And then the most mind-blowing event occurred: cosmic inflation. Inflation was an ultra-fast expansion of the universe, so fast that it grew by a factor of a trillion in a fraction of a second. This sudden growth smoothed out the universe but also created tiny ripples in space, known as gravitational waves. These waves rippled through the baby universe like water in a pond. And the CMB carries the imprint of those waves. They left behind subtle patterns in the polarization of the ancient light. By studying these patterns, scientists can learn more about the early chaos that gave rise to everything we see today. To dive deeper into this cosmic baby picture, NASA has developed a new observatory named Piper, which stands for the Primordial Inflation Polarization Explorer. Think of Piper as a high-tech cosmic detective. It's basically a super-sensitive telescope that's going to ride into the upper atmosphere on a giant balloon. The balloon will launch from a site called Fort Sumner in New Mexico, and the observatory will scan 85% of the sky, looking for those delicate imprints left by inflation and gravitational waves in the CMB. Piper isn't your average telescope. It has two highly advanced instruments housed inside a container about the size of a hot tub, which is filled with liquid helium. Why helium? Because it keeps the instruments super cold, around -452 degrees Fahrenheit. That extreme chill is essential for detecting the faintest signals in the CMB without interference. The colder it is, the better Piper can pick up even the tiniest variations in the ancient microwave glow. And with this level of sensitivity, it might reveal clues about how space and time first emerged. Piper's mission is incredibly ambitious: to uncover the hidden signatures of the universe's birth. By analyzing the light from nearly 14 billion years ago, it aims to answer big questions like, how did inflation work? What forces shaped the cosmos? And could there be new physics beyond what we currently understand? It's like examining an old photograph under a microscope, hoping to find details that no one has ever seen before. These answers could forever change how we understand the universe and our place within it. The launch of Piper is scheduled for late September, and the excitement is real. You'll even be able to watch the balloon launch live on the Columbia Scientific Balloon Facility's website. It's a space mission with a twist. Not a rocket, but a giant helium balloon carrying some of the most sensitive instruments humanity has ever built. Floating high above the Earth, free from atmospheric interference, Piper will give us the clearest view yet of the oldest light in the universe. It's a truly out-of-this-world adventure for science. In the end, the cosmic microwave background is more than just a faint glow. It's a time-traveling storyteller. It holds the memories of a time before galaxies, stars, or even atoms. It tells us how the universe grew from a seething quantum foam into the vast cosmic tapestry we see today. And with tools like Piper, we're getting closer than ever to unlocking those stories, reading the universe's diary from its earliest pages. Space is full of mysteries, and the CMB is our guide through the beginning of it all. To witness one of the most incredible astronomical events ever observed, we head straight to South America, to the vast and silent Atacama Desert in Chile. Here lies some of the most advanced astronomical technology on Earth. This desert is home to giant telescopes operated by elite scientists from the Royal Astronomical Society. For over 6 months, these astronomers closely monitored something beyond extraordinary: a massive black hole slowly consuming a giant star. This wasn't just a typical cosmic event, it was a jaw-dropping spectacle that revealed the true power of these cosmic beasts. Interestingly, these same scientists had previously proven that at the heart of our own Milky Way galaxy lies a supermassive black hole, and they even captured its image for the first time in human history. What made this event even more astonishing was its proximity to Earth. Well, in astronomical terms at least. The cosmic devouring occurred a mere 215 million light-years away, which in the vast scale of the universe is considered relatively close. The light from this astonishing event reached Earth in September 2019, and even the most seasoned astronomers were left in awe. To put this into perspective, imagine a star similar in size to our Sun, roughly 860,000 miles in diameter. Stars of this size have enough mass to exert powerful gravitational pulls, often holding entire planetary systems in stable orbit. Now, picture placing a monstrous black hole next to it, a completely dark, disc-shaped entity weighing billions of times more than the star. The gravitational force of such an object is so immense that not even light can escape it. As soon as a star wanders too close to a black hole's gravitational pull, its fate is sealed. At first, the star resists, trying to hold its form, but it's a losing battle. The intense gravity begins stretching the star's outer layers toward the black hole. This strange process is known as spaghettification. And yes, the name is fitting. If you could stretch your hand toward a black hole, you'd literally see your fingers start to stretch and thin out, because the pull gets stronger with each inch. The force acts more on your fingers than your arm, elongating them like strands of pasta. It's weird. It's terrifying. It's real. This extreme gravitational stretching begins to peel off the outermost layer of the star, called the corona, which is made of searing hot plasma. Now the star begins to visibly shrink, losing mass and light. That bright plasma layer, which makes up most of the star's glow, is now being ripped apart and funneled toward the black hole. From a distance, it might look like this plasma hovers around the black hole's edge, spinning like a fiery halo, but don't be fooled. Those particles have already crossed the black hole's event horizon. There's no return from that point. A black hole's gravity even bends light around its edge, making the event horizon look a little like a croissant to the human eye. Funny how all these descriptions keep sounding like food metaphors. Spaghetti, croissants, it's making me hungry. But back to space. When you observe the event horizon, you might see what looks like chaotic streams of light moving in opposite directions. That's because of a mirror-like visual illusion. Regardless of what it looks like, once anything passes that threshold, it's on a one-way trip into the singularity, the mysterious center of the black hole. Interestingly, objects approaching a black hole appear to slow down dramatically. This isn't an illusion, it's due to how black holes warp spacetime. The more massive an object, the slower time flows around it. So if you hung a watch near the event horizon and compared it to one in your room, you'd notice the watch near the black hole barely ticks. For the observer, the light and matter seem to move slowly, but in reality, it might already be long gone. absorbed ages ago. But wait, it gets more spectacular. As the black hole devours the star, it ejects blazing streams of red-hot plasma into space. These jets blast outwards at an insane speed of around 6,200 miles per second. This violent release of energy creates a flash so powerful, it's the only reason we can observe this process at all. This bright outburst is similar to what we see during a supernova explosion, though it's a completely different mechanism. Even when the star's body is almost gone, remnants like stardust and glowing debris linger near the event horizon, resembling, yes, you guessed it, Parmesan cheese scattered on a plate of spaghetti. Okay, I'll stop. Maybe. By the end of the process, nearly half the star's mass has been ejected into space as glowing dust and particles, while the rest vanishes into the black hole forever. Astronomers were able to study this stunning transformation for 6 full months. But let's take things a step further. What would happen if you could fall into a black hole? Of course, we can't actually do that yet, but let's simulate it. Imagine a small drone, our little metal friend, floating like a meatball in space. No, seriously, bear with me. It's currently hovering at a safe distance from the black hole, roughly 3 times the width of the event horizon. At this range, objects can orbit the black hole without getting pulled in. This safe zone isn't just for show. Planets could technically exist here too as long as there's some nearby star providing warmth and light. Under the right conditions, life might even be possible. But our mission isn't safety, it's curiosity. So we guide our drone closer. As it nears the event horizon, the gravitational force starts pulling harder. The drone stretches like spaghetti again, and once it starts spinning uncontrollably around the disk, it's officially crossed the point of no return. From here on, the descent is inevitable. Now let's shift our view to what the drone sees. As it falls, the light from surrounding stars begins to turn blue, a phenomenon called gravitational blue shift. It happens because the gravitational field compresses the photons of light, boosting their energy and shortening their wavelengths. So the red light turns blue, and everything seems to speed up and grow more intense. But eventually the drone is no longer visible. It's swallowed by darkness. Inside nothing exists. No light. No time. Time as we know it slows to an imperceptible crawl. A single minute spent inside the black hole could equal billions of years outside. While our entire solar system could form, evolve, and die out, the drone would still be falling. Strangely, the drone suddenly detects a faint light. That beam grows brighter and starts drawing closer. It's as if the drone is falling again, but in reverse. The light around it slowly shifts from blue back to red, and in theory, it's being spit out into another region of the universe. Could it be emerging in some distant galaxy? Possibly. Some theories suggest that black holes might actually be wormholes, cosmic shortcuts to other areas of space and time. However, as fascinating as that idea is, it's still unproven and mostly belongs in the realm of science fiction. For now, one thing is certain: black holes are incredibly hard to detect. Why? Because they're black, like the surrounding space, and emit no light. The only way we know they exist is by observing how they affect the space around them, especially gravity. When a nearby star or planet behaves strangely, bending or accelerating in odd ways, it usually points to the invisible presence of a black hole. Despite their elusive nature, scientists believe that black holes are everywhere. They're born when massive stars collapse under their own gravity. And given the sheer number of stars in the universe, black holes might actually be quite common. Interestingly, they don't live forever. According to Stephen Hawking's theory of Hawking radiation, black holes slowly lose mass over time. To survive, they must keep devouring material, like stars or gas clouds. If they're isolated in deep space with nothing to consume, they gradually shrink and eventually disappear. A cosmic end for a cosmic monster. Just like that plate of spaghetti that, well, now it's completely gone. One of the most remarkable discoveries made by the James Webb Space Telescope is the detection of smoke molecules in a galaxy so distant that it's almost unbelievable. This galaxy lies approximately 12.3 billion light-years away from Earth, meaning it likely formed just 1.5 billion years after the Big Bang. What's astonishing is that scientists managed to identify chemical compounds typically found in soot or smoke, substances never before detected this far from our planet. This groundbreaking finding pushed the record for detecting complex molecules back by almost a billion years, giving us a glimpse into chemical processes that occurred in the early universe. The discovery becomes even more impressive when you consider the technical difficulties involved. At the time of the measurement, the spectrometer on board the Webb telescope had suffered a surprising degradation. Even so, the telescope still managed to pick up these chemical signatures. This proves just how powerful and capable this instrument truly is. It stands as a testament to the engineering behind it, showing that even when it's not performing at full capacity, Webb can still detect incredibly subtle chemical fingerprints in galaxies formed near the dawn of time. Webb's capabilities don't stop there. It has also taken the study of exoplanets to the next level. In early 2023, it observed an exoplanet named LHS 475b. This planet is located around 41 light-years away from Earth and is almost identical in size to our own planet. It marks a historic moment, as it's the first Earth-sized exoplanet observed in such detail by Webb. Right now, Webb is the only operational telescope with the ability to characterize the atmospheres of Earth-sized exoplanets, making it a game-changer for the hunt for potentially habitable worlds. The research team that made this discovery emphasizes how precise Webb really is. They're optimistic that it will allow us to identify many more rocky exoplanets, possibly leading to future targets for human colonization. Even though the vastness of space might give the illusion of emptiness, it's anything but quiet. The universe is filled with action, and Webb has the perfect set of tools to witness cosmic events we could only dream of seeing before. Every image it captures reveals just how dynamic and chaotic the universe truly is. Take the image of WR24 for example, a star captured in its final, dramatic moments. In this image, the star is approaching the explosive phase of its life, a supernova. A supernova occurs when a massive star runs out of fuel and collapses in on itself, creating a powerful explosion that flings hot gas and dust across space. WR24 was caught at the Wolf-Rayet stage, a period during which a star sheds its outer layers just before exploding. Thanks to Webb, we're witnessing this cosmic spectacle in astonishing clarity. Then there's the unusual discovery of VHS 1256b, a celestial body that falls into the strange category of a star-planet hybrid known as a brown dwarf. These objects are larger than planets but too small to ignite nuclear fusion and become stars. Even though they emit some light and heat, they lack the mass needed to truly shine like stars do. What's especially fascinating about VHS 1256b is that it has weird clouds made not of water vapor like Earth's, but of something far more alien, sand. And not just any sand but tiny particles of a material called silicate. This brown dwarf is a true heavyweight, nearly 20 times the size of Jupiter, and it orbits two red dwarf stars. To complete just one orbit it takes more than 10,000 years. Astronomers had actually detected this mysterious object back in 2016, but they couldn't determine what it was or why it had such an odd reddish glow. It wasn't until the James Webb Telescope came into play that its true identity and composition were uncovered. That glow? It's the light reflecting off the silicate clouds, another reminder that the universe is full of surprises. In another twist, Webb stumbled upon several massive galaxies that should not even exist by conventional cosmological standards. These galaxies are estimated to have formed just 500 to 700 million years after the Big Bang, which is incredibly early in the universe's history. Even more baffling, these galaxies are as massive as the Milky Way and contain mature red stars. That means they somehow formed, evolved, and aged at a rate far beyond what current theories can explain. It's a discovery that forces astronomers to reconsider what we think we know about galaxy formation in the early universe. And then there's the image Webb captured of Pandora's cluster, a region of space where three massive galaxy clusters are merging to form a colossal megacluster. Due to the sheer gravitational force of the combined clusters, light from even more distant galaxies is bent and magnified. This phenomenon, known as gravitational lensing, allows astronomers to peer deeper into space than ever before. Thanks to this cosmic magnification and Webb's unmatched resolution, scientists were able to spot galaxies that might otherwise remain invisible. The image of Pandora's cluster is by far the deepest and clearest ever captured of this region. The telescope has also zeroed in on the Tarantula Nebula, the largest star-forming region in the local group of galaxies. Named for its dusty filaments that resemble spider legs, this nebula is a hotbed of newborn stars. Webb's high-resolution infrared images have revealed thousands of stars that had never been seen before. Among them are protostars, infant stars still forming and gathering mass. These protostars are expected to eventually shape and change the nebula itself. It's like watching stellar evolution in real time, and Webb offers a front-row seat to the show. Alongside those baby stars, Webb also witnessed the birth of 50 distant stars, some of which are powering protoplanetary disks. These swirling disks of dust and gas could eventually form entire solar systems. It's incredible to think that Webb is observing cosmic nurseries where new worlds might be born. And while peering into these dusty cradles of creation, Webb captured an image of a supermassive black hole with the mass of 9 billion suns. This ancient behemoth is so massive and old that it challenges our understanding of how such objects could have formed so early in the universe. In another breakthrough, Webb detected a dusty ring filled with rock and gas, which contains a chemical compound called methyl cation. This molecule is one of the key building blocks of life as we know it and plays a major role in forming organic material on Earth. The fact that Webb can spot this molecule in such distant environments means we're one step closer to understanding how life might originate elsewhere. Webb also detected violent sandstorms on a planet located 235 trillion miles away, an achievement that opens new doors for studying alien weather systems on distant worlds. And of course, we can't forget the iconic pillars of creation. While Hubble first captured this star-forming region in 2014, Webb has returned with an image so detailed that it's like seeing the same scene in Ultra HD. Where Hubble showed haunting columns of gas and dust, Webb's version reveals an explosion of newborn stars embedded in those columns. The difference is mind-blowing and stands as proof of just how much progress we've made in astronomy. It's no longer just about seeing stars, we're now observing their births, lives, and sometimes, their explosive deaths with unprecedented clarity. But Webb isn't the end of the story. In fact, we're only getting started. NASA has another powerful tool on the way, the Nancy Grace Roman Space Telescope, expected to launch in 2027. While Webb and Hubble specialize in high-resolution close-ups, Roman will take the wide-angle approach. It will be capable of capturing images 200 times larger than Hubble, with the same level of detail. That means where Hubble had to stitch together 400 separate images to form a mosaic of the Andromeda Galaxy, Roman could achieve similar results with just 2 images. This wide-field capability is revolutionary. With it, Roman will collect data at a scale never before possible. It's like upgrading from a telescope that gives you a detailed view of one puzzle piece to one that shows the entire puzzle at once. NASA and scientists hope this panoramic view of the cosmos will help answer some of our biggest questions, including whether Einstein's theory of general relativity holds true across the universe. We've tested the theory within our solar system, but Roman might finally let us test it on a cosmic scale, by tracking how visible matter and dark energy interact. Einstein's theory predicts that gravity should slow the universe's expansion, but observations show that the universe is actually expanding faster over time. Scientists suspect this is due to a mysterious force called dark energy, which is thought to make up nearly 70% of the cosmos. Roman is designed to help us map the universe's expansion rate in different regions, potentially confirming or challenging Einstein's ideas. If successful, it might provide the most accurate measurements yet of how fast the universe is growing and whether our understanding of gravity needs a cosmic rewrite. Roman will also focus heavily on exoplanet hunting. Using a technique called gravitational microlensing, it will detect planets by watching how their gravity distorts the light from stars behind them. This technique is incredibly sensitive and could uncover hundreds of thousands of exoplanets in our galaxy. By doing so, Roman will provide one of the most comprehensive censuses of planetary systems ever made. And it won't just count them, it will help us understand how common Earth-like planets really are, where they exist, and what kind of environments they might offer. Another cutting-edge instrument on board Roman is the coronagraph, designed to block out a star's bright light so scientists can see the dim planets orbiting nearby. This technology is incredibly difficult to execute because starlight can easily overwhelm the faint glow of a planet. But Roman's coronagraph will use real-time corrections to suppress that starlight, allowing for direct imaging of large Jupiter-like exoplanets. If successful, it will be a major step toward future missions that aim to directly photograph Earth-like worlds and habitable zones, planets that might one day host life or even humans. But Roman isn't the only big idea on the table. NASA and other organizations are also exploring revolutionary concepts like the Nautilus Project, a proposed space observatory designed to multiply our ability to detect life-friendly planets across the galaxy. These efforts signal a new age of space exploration where we're not just looking at stars, we're actively preparing to understand, explore, and maybe even visit the worlds orbiting them. In the realm of space exploration, groundbreaking technologies are constantly emerging, and one of the most promising developments is the Nautilus telescope. This new space telescope, built on a novel technology utilizing special optical elements, has the potential to overcome some of the major limitations that current space telescopes face, particularly the issue of non-scalable primary mirrors. The Nautilus technology enables the creation of large yet ultralight telescope apertures. This breakthrough could facilitate the launch of a fleet of identical telescopes, all possessing impressive light-collecting power. These telescopes will be capable of surveying thousands of Earth-sized planets located in the habitable zones of their stars. This could allow us to detect atmospheric signatures of life on distant planets, a goal that has eluded scientists for years. Over the past 2 billion years, Earth's atmosphere has changed dramatically, with the abundance of free molecular oxygen and ozone, highly reactive gases, combined with water vapor and methane, creating a unique atmospheric composition. These gases, known as biosignatures, signal the presence of life, and detecting them on distant planets would be a groundbreaking achievement. To detect these atmospheric fingerprints from light reflected or transmitted through the atmospheres of Earth-like planets, large telescopes are essential. The Kepler mission has already discovered more than 4,000 exoplanets, but no existing or planned space telescope has the required diameter to effectively search for life in the atmospheres of these planets. The Nautilus team aims to create a telescope capable of studying thousands of Earth-like planets, bringing us one step closer to answering one of the most profound questions in science. Are we alone in the universe? Another exciting space mission is the European Space Agency's Euclid mission. Named after the ancient Greek mathematician who founded geometry, the Euclid mission aims to explore the composition and evolution of the dark universe. Dark energy and dark matter make up most of the universe, yet their nature remains a mystery. Dark energy accelerates the expansion of the universe, while dark matter controls the growth of cosmic structures. By observing billions of galaxies across more than a third of the sky, Euclid will create a 3D map of the large-scale structure of the universe, offering insights into how the universe has expanded and evolved over time. The Euclid mission, which is about 15 feet tall and 12 feet wide, consists of a payload module and a service module. The payload module includes a 4-foot diameter telescope along with 2 scientific instruments, a visible wavelength camera and a near-infrared camera or spectrometer. The service module houses the satellite systems necessary for power generation, data processing, thermal control, and more. Through this mission, scientists hope to uncover the secrets of dark energy, dark matter, and gravity, potentially revolutionizing our understanding of the universe. In 2020, astronomers made an astonishing discovery: strange, repeating, and powerful radio signals originating from deep space. These signals, unlike anything previously observed, appeared sporadically and disappeared without warning. Initial attempts to identify the source of these signals failed to match any known cosmic phenomena, such as pulsars or magnetars. The closest match came from a mysterious class of objects known as galactic center radio transients (GCRT), located near the center of our galaxy. These enigmatic radio sources could hold the key to unraveling some of the deepest mysteries of the universe. Speaking of the vastness of space, a fascinating comparison of distances puts into perspective the scale of our solar system and beyond. For example, Proxima b, the closest Earth-like planet to us, is located about 4.24 light-years away. If you traveled at the speed of the Apollo moon rockets, 25,000 miles per hour, it would take over 112,000 years to reach Proxima b. The challenges of interstellar travel are immense, as even reaching the nearest star would require technology far beyond what we have today. Our universe, as vast as it is, remains largely invisible to us. Only about 5% of the universe is visible matter, while the remaining 95% consists of dark matter and dark energy, elements that we cannot see or directly detect. The first person to realize the importance of this invisible matter was Albert Einstein, who proposed that space itself is not empty but filled with unseen forces. This dark matter and dark energy make up roughly 27% and 68% of the universe, respectively, shaping the structure and evolution of the cosmos. Even the seemingly mundane, like water, behaves differently in space. If you were to pour water in the vacuum of space, it would immediately vaporize due to the lack of air pressure. On Earth, water boils at a much higher temperature due to atmospheric pressure, but in space without air pressure, water boils at a much lower temperature. This phenomenon illustrates the unique conditions astronauts must navigate when working in space. In terms of the scale of the universe, scientists estimate that there are at least a couple of billion galaxies scattered throughout the cosmos. However, this is just an approximation, as the true number may never be known. Our own Milky Way galaxy alone contains at least 100 billion planets, a staggering number that suggests the potential for countless worlds beyond our own. On a more tangible note, let's consider the experience of floating in space. In the absence of gravity, astronauts' spines stretch, making them temporarily taller by about 2 inches. This is just one of the many strange effects of weightlessness. Space suits, necessary for survival outside the safety of spacecraft, are incredibly complex and expensive. It can take up to 5,000 hours to construct a space suit, which can cost over $1 million to make. These suits are not only expensive but also incredibly heavy, weighing around 110 pounds. Despite the challenges, astronauts rely on them to perform tasks in space, where the absence of air pressure and gravity creates a vastly different environment than on Earth. The vastness of space also means that sound cannot travel, as molecules are too far apart to transmit sound vibrations. This fact debunks many science fiction movie portrayals of sound in space, where explosions or engine noises are heard. In the real vacuum of space, no sound can be heard, leaving a haunting silence. In the grand scheme of things, we may be closer to the Sun than we think. Earth's orbit actually passes through the outer atmosphere of the Sun, known as the heliosphere, which extends far beyond the surface we can see. The solar wind, which creates phenomena like the northern and southern lights, is evidence of this extended atmosphere. Despite being millions of miles away from the Sun's surface, we are effectively living inside its outermost layers, a realization that reshapes how we think about our place in the universe.